Hey there, students. We'll be working out of page 181 today, and we are going to look at determining whether a sequence is arithmetic, geometric, or neither. Now, arithmetic we should be comfortable with by now, hopefully. We know that if a sequence of numbers is arithmetic, then you're either adding or subtracting by the same number. With a geometric sequence, which is new today, we're going to look at, are we multiplying each term? Are we multiplying the first term by a number to get the second term? And then are we going to multiply by that same number throughout to create the rest of the sequence? So let's look at number one here. And I can see that my sequence contains four numbers: 1, -4, 16, and -64. And kind of the first thing I realize is that I'm alternating from positive to negative. So I have a +1, a -4, a +16, and -64. So immediately I know that that can't be arithmetic because there's no way that I can add the same number to 1 to get -4 and also get 16. And there's also no way that I can subtract the same number from 1 to get -4 and then subtract it again to get +16. So immediately I know that that can't be arithmetic. It's possibly geometric, but now I have to figure out what number am I multiplying by each term to get the next term. So first, let's look at 1. Kind of consider what could I multiply by the number 1 in order to get the number -4. And so hopefully we know that if I multiply 1 by -4, well, that is going to get me -4. So 1 times -4 is -4. Well, and then if I continue that multiplication, so if I multiply, and actually, you know what? I'm going to change this. Instead of the multiplication symbol, as they show in the book, I was going to do times, like a little dot, and then -4. So we can show multiplication that way. Same thing here. If I did times -4, well, I know that -4 times -4 is going to be +16. And I do the same thing here, times -4. So negative or +16 times -4 is going to be -64. Now, if you're unsure of that, let's say you really don't know, then in your calculator, so new document, add a calculator, start with the first number, 1, try out -4, so it works, -4, and then times that by -4, so it's going to take the answer multiplied by -4, we get 16, times that answer by -4 again, and then we get -64. So that creates our sequence that we've been looking at. And so in this case, we can say that this is geometric. And it's only geometric because we're multiplying each term by the same number. So we can write that down. We are multiplying each term by -4. So geometric. So now let's look at number 2. Look at number 2. I have 3, 7, 11, and 15. So immediately we can kind of look at each of these terms as increasing. Unlike number 1, where it was alternating in the sign value, so positive, negative, these are all increasing. And so we very well could be multiplying by a number, as with geometric, or we could be adding by a number, as with arithmetic. So because these numbers are not increasing that quickly, that makes me believe that, hey, this might be arithmetic. So I may want to first start there and figure out, can I add something to 3 to get to 7? And then can I take that number and add it to 7 to get to 11? And can I take that same number and add it to 11 and get to 15? And so when I look at this one, I think to myself, what number can I add to 3 to get to 7? Well, that number is 4, right? If I take 3 and I add 4 to it, I get 7. Well, if I continue to add 4, so 7 plus 4 is 11. And if I add 4 more, 11 plus 4 is 15. So this would be an arithmetic sequence because we're adding the same number each time. So I can classify number 2 as arithmetic. And that is because we're adding the same number each time. So adding positive 4 each time. Now for our last example from numbers 1, 2, and 3, here we are looking at this sequence of numbers. I go from 2, I go from 4, I go from 8, and I go from 32. So just like number 2, we're increasing in value. And so you may think to yourself, hey, maybe we're adding something again, and that's a possibility. But we're increasing our value rather quickly. We start with 2 on the first term, and by the fourth term, we're at number 32. So that makes me think that we could be multiplying by something. But if you don't know, it won't hurt to try out both. So let's say that we might think, this might be arithmetic. So let me see if I can add something to each term. Let's see if we can add the same number to each term like we did in number 2. So what number could I add to 2 and get to 4? Well, I can add 2. So if I do plus 2, that gets me to 4. And then, well, what number can I add to 4 to get to 8? Well, that would be plus 4. So automatically, it's not arithmetic. So I can eliminate that. It's not arithmetic because it's not the same increase. So I know that can't be it. So now let's go with the geometric and let's figure out, well, what number can we multiply? So what number could I multiply by 2 to get 4? Well, I can multiply by 2. So if I do times 2, 2 times 2 is going to be 4. Okay. And I can also multiply 4 times 2. So if I do 4 times 2, that's 8. And this one, well, that's not going to be times 2. 8 times 2 is 16. So that's not times 2. Here, I'm actually multiplying by 4. So that doesn't work either. Because it's not arithmetic and it's also not geometric, then we classify this as neither. So that is an option. Over here at the very end, it says it could be neither. So this one we would just write down the words neither. And it's neither because we're not adding or subtracting by the same number and we're not multiplying by the same number. So we are not adding or subtracting or multiplying by the same number. So now I want you to look at numbers 4, 5, and 6 right below number 1, 2, and 3. And I want you to tell me which one of these sequences is geometric, which one of these sequences is arithmetic, and which one of these sequences is neither. And then after you finish that, I can check it. And then I want you to go on to numbers 7, 8, and 9, and 10, 11, and 12. And 7, 8, and 9, you're already being told that this is a geometric sequence. So you don't have to determine that. It's been stated that, hey, this is already geometric, all of these 6. You are only to determine what are the next 3 terms in the sequence. So I'll do number 7 with you, actually, just to give you an example of that. So since we know that it's geometric, that means we have to multiply something by the first term to get the second term. So if you are unsure of what you're multiplying by, then you can always divide those 2 numbers. So let's say I really don't know, hey, what am I multiplying by 7 to get 21? Then I can actually divide 21 and 7. and that will give me the number that I'm multiplying by. And so this is 3. Now, this term, or this 3, actually has a name, and that name is called the common ratio. And so as long as the common ratio is the same for each of these, with just the number we're multiplying by, then that is what makes it geometric. But for 7 through 12, we don't really have to determine if it's geometric, because once again, you're being told, hey, these are all geometric. You just have to find this number. So now that I know that I'm going to multiply 7 times 3 to get 21, so 7 times 3 is 21, which means if I take that times 3 again, if I do 21 times 3, I'll get 63. And if I multiply 63 by 3, I should get 189. Now I want to find my next 3 terms. And to do that, there's no harm in using that trusty calculator. So if I have 7 times 3, so that's 21. If I multiply that by 3, we get 63. If I multiply that by 3, and we get 189. So I want the next 3 terms after that. So if I do times 3 again, this is the next term after 189, times 3 again. This is the next term after 567, and then times 3 again, and that's my last term I'm looking for. So when it wants the next 3 terms, it wants 567, 1701, and 5103. So we go back to our paper, my next 3 terms, dot, 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 kind of continue on the pattern, 567, 1701, and 5103. And so that's going to be your objective for number 8, number 9, number 10, 11, and 12. Figure out what number you're multiplying by. If you can't figure that out just by looking at the numbers, then it's okay to divide the first 2 numbers, and that will give you the number you're multiplying by. And then you use that to find the next 3 terms. If you have any issues or questions, feel free to ask. That's what I'm here for. You always see me walk around the classroom, so don't sit there and be lost. Thank you.